Alright, hey guys, what's up? We're just continuing here with the next two learning objectives on the syllabus in section 9 for matrices, right? Wow, that's kind of too thick, right? For matrices, which is section 10 and section 11. Cool. Alright, so the first section says, the first objective says, define the multiplicative inverse of a non-singular square matrix, colon, identity the square matrices. And 11 says, obtain the inverse of a non-singular 2 by 2 matrix. Okay, and it says colon, the determinant and the adjoint matrix. Okay, so this is cool. So what we're gonna do first is we're gonna define some things before we actually just go straight into the inverse. Let's talk about some things first. In the last video, we already did the determinant, right? So let's just go over that. Let's just clear this and go over that for a second. All right, so for the determinant, right? Let's go over that real quick. Oh, man, not too pretty, but for the determinant, let's call the matrix A, right? A, B, C, D. The determinant, right? DET. Oh man, that's not looking too good, man. All right, let's write that a little better. DET for short. The determinant of A is equal to AD minus BC, right? Cool. If you don't know what this is, you can look in the last video for the determinant, and you should get an idea of what I'm talking about. I did some examples there, so you can double check on that, right? So we define that. Now let's define something else, right? Okay, guys, so we're gonna define uh, another property in matrices, basically, called the adjoint matrix, okay? We already did the determinant, so we're gonna look at the adjoint matrix, okay? Adjoint matrix. Okay, awesome, dude. Okay, so all right, so we're gonna find the adjoint matrix for A. In this case, we're gonna use A, B, C, and D because we are defining it. So all you have to do is to find A adjoint, right? All you have to do is switch the main diagonal, right? Switch the two numbers in the main diagonal. In this case, it's D and A, and put a negative sign on the other diagonal. So that's negative B and negative C. And this is A adjoint, right? Right, great, awesome, right? Not hard at all. Pretty simple. Okay, so let's do two simple examples in this case. No, let's do three simple examples in this case. It's always good to do three examples. All right, so let's clear this and let's use some real life examples. Let's say A is equal to 1, 2, 3, 4. My lovely easy example here. Okay, and let's find A adjoint, right? Let's find A adjoint. A adjoint should be, you switch the main diagonal, right? So that's 4 and 1 there. And then you just put a negative sign on the 2 and a negative sign on the 3. Pretty easy, right? Awesome. Not hard. I love it. Really not too bad. I think we can manage this. We can manage this, guys. All right. So let's do two more examples. Let's clear that quickly. And next example, let's use P is equal to 1, 3, 4, 14. Okay, let's use that. Okay. All right. So to find P adjoint, in this case, we can just say ADJ for short, which means adjoint. P adjoint is equal to, you switch the main diagonal, so that's 14, 1, and then you put a negative sign on that 3 and a negative sign on that 4. And that's for P adjoint, right? Cool. Looking simple, guys. You know, really not too bad. This guy is smiling off his teeth here. Really looking good, you know. All right, so let's clear this and do another one. Um, okay, let's call this one C, right? C is equal to, let's use another example, 8, 4, 1, 3. Cool. And let's find C adjoint. We're going to use ADJ for short, right? Is equal to, we're going to switch the main diagonal. We're going to get 4, 8, then we're going to get -3 and -1. Cool. Awesome, guys. Really easy in my opinion, right? Really not too bad. And yeah, I think this is manageable. And it's really simple when you think about it. And we need this to find the inverse, okay? So we're going to check out the inverse in the next video. Awesome. So see you later, guys.